Guys, I'm back with another example on the composition of trig functions with inverses. Guys, here we have a function which is slightly different than any of the functions that we have seen in my previous videos. Guys, here I have a cosine and then there's a sine inverse. Well, obviously we can see that they are not inverses of each other. This is a different function than the sine inverse. And then again, the other thing which is different for in this example is the ratio or this number which is 3/5. That 3/5 we know is not visible on the unit circle, so we have to do something else in order to actually simplify or find the value for this particular composition of trig functions. So guys, the first thing that we are going to do is we're going to start working from the inner, and obviously that would make sense starting from the inner, and that's exactly what we did in my previous example where we had a tan inverse -1 inside, like as an inner function. But tan inverse -1 is something that we could evaluate or we could find from the unit circle because it was on the unit circle, so that made life a little bit easier for us. But here 3/5 obviously is not on the unit circle, so we have to do some extra work to evaluate this function. But guys, it's not going to be too complicated. All we have to kind of start with is, first of all, we have to try to evaluate what is the value for sine inverse of 3/5. And we cannot like directly find that. So if we cannot directly find it, then what we are going to do is we're going to say let that equal to theta. Okay, or any variable for that matter, because with angles we always like to put them as thetas or phi or alpha, beta, but it's up to you, whatever you want to choose. So I like to use theta here. Now this we know is equivalent to finding sine of theta is 3/5, right? This equation is same as this inverse equation is equivalent to saying sine of theta is 3/5, and our goal is to solve for that theta. So solving for theta is our first goal in this case, right? And guys, if this ratio or this number on the right hand side was on the unit circle, then we would just look in the unit circle and just identify that angle theta for which the sine of that angle is that ratio. But since 3/5 is not on the unit circle, that does not mean we cannot do it. Guys, we can still do it. All we have to do it, we have to kind of go back to like the first or second lesson of the trig course, where we talked about the basic rules or basic ideas of sine and cosine and other trig functions. I'm talking about the basic definitions. What is the sine? Sine is the opposite over hypotenuse. So guys, we have to bring those simple basic ideas back. Based on that, first of all, what I'm going to do is I'm going to draw a reference triangle, and then from that we will be able to find the value of this composition function. Again, keep in mind 3/5 being a positive number, right? And we know it is still between -1 and 1, and then it's a positive quantity. Obviously, since it's positive, it's going to be in the first quadrant, right? And we know that sine inverse is only between -pi/2 to pi/2, so it can be either in the first or in the fourth, but being a positive quantity, it has to be in the first quadrant. So I will draw my reference triangle. Guys, drawing my reference triangle, this is my theta. So I'm drawing the reference triangle for this particular equation, right? Keeping in mind that it can only be in the first quadrant because sine inverse is only valid in the range is only valid from -pi/2 to pi/2, which we know is between only first and fourth. So guys, from this we know this is opposite over hypotenuse. That means this is my 3. Obviously this is going to be my 5, and what is the base or what is the adjacent? So the adjacent, if you remember, this is a special triangle, 3, 4, 5 triangle. If you don't remember that's 3, 4, 5 triangle, then one has to use the Pythagorean theorem, and one can basically evaluate the value for the adjacent. Guys, the adjacent is going to be 4, okay? And if you're not seeing why I'm finding out adjacent, guys, it will be very clear like in a second once I substitute things back. Guys, if we say that this equals to theta, now let us look at this expression. What is this going to be? It's going to be cosine of this function, but we are saying that let this be theta, so this is just going to be theta, right? So by setting this equal to theta, we understand we are trying to find the value for that theta, but we don't really know that theta here because it is not on a unit circle, and we don't really need to find the value for that angle here. Guys, keep in mind our goal is to find the composition of this whole thing. Our goal is not to find theta. If we can find theta sometimes, that might help us to finally evaluate the composition. But in this case, finding theta is not going to really help one. So we just set it equal to theta. We understand that this equation is equivalent to saying sine of theta is equal to 3/5. from this equation we can set this reference triangle in the first quadrant. I have this reference triangle with all the sides, and when I substitute this guy back into the original function, basically it just transforms into cosine of theta. So if we can find the value for the cosine of theta, we have in turn found the value of this given composition function. Okay, that it is as simple as that, but you have to like see it for once, you have to see how it works one time, and then you can start using it for other examples of the similar type. So finding the cosine theta, we don't have to really think too hard. It is the theta, the reference angle is same as the reference angle here. It's the same theta. I have this nice right triangle. Can I find the cosine theta for this triangle? Yeah, cosine theta we know is what? Cosine theta is the adjacent over the hypotenuse. Adjacent we already know is 4 and hypotenuse is 5. And guys, that is the final answer for this composition function. Okay, so guys, this was slightly different than any of the other examples that we did so far, but this is also something that you should know, because these things may also come handy when we simplify expressions which involve trig functions and their inverses, or even when we solve equations, and especially those numbers that are not on the unit circle. Okay, so guys, this is number 4. I will see you next time with another